we're going to continue to explore some problems dealing with betweenness, this concept, and distance. So our very first question here, well, really for all of the questions, we want to make sure that we're drawing a number line and making sure to show all our work. Okay. Question number 1. Points A, B, and C lie on a number line, with A located at -4. It's a good idea to put that point, that specific location, right in the center of the line. And then a distance from A to B. See, this means distance when there's no symbol up here. So the distance from point A to point B is 6 units, which means we're going to travel from A up to B 6 units. And -4 plus 6 is 2. So the location for B is 2. You could, of course, write all of these marks, -4, -3, -2, -1, 0, 1, and then 2. That would change where we are. Or just use the math of adding 6 and also subtracting 6. Because they didn't tell us a direction from A to B, they just said that we were going to travel 6 units. So we could have gone 6 units in the negative direction on this number line, and we'll call this point B2, which will make this first one B1. And that's at -10. Okay. Next part of the problem says if AC is 1/2 as long as AB, that is a math sentence written in English. And in mathematics or algebra, the distance from A to C is or equals 1/2 as long as the distance from A to B. Well, we know that AB is 6 units. So I can substitute 6 units for that distance into this equation. And the distance from A to C is 1/2 of 6, or 3 units. Now the question asks, where is C located? So not a distance, but a location for point C. That's going to be somewhere halfway between points A and B. And it could be on the right or left side, because we could travel 3 units this way, or 3 units this way. And so -4 minus 3 is -7. And -4 plus 3 is -1. So we know that C is located at -7 or -1. And if you want to check your answer at the end here, if AC is 1/2 as long as AB, that would mean 3 units from A to C and then 3 more units to B. Or 3 units from A to C2 and 3 more units to B2 from C. And that does check out. We are exactly halfway between A and B. Question 2 is a little different. This time, they tell us there are 4 points on a number line in alphabetical order. So we'll draw our number line. And we have R, S, T, and U. And these are not in any kind of scale order. They're in just alphabetical order, but the scale between them is not accurate. They tell us that the coordinate for point R is negative 1.3, and U has a coordinate of 7. Then they give us some distances. The distance from R to S is 3 units. And again, we know their distances because RS is written next to each other with no symbol above it. So that's a distance. And TU is a distance of 1 unit. So there are 2 ways you could answer this question. What I find to be the most easiest is to find the total distance, RS, and then subtract, I'm sorry, not RS. RU is the total distance. So the whole distance, RU, and then subtract the distance of RS plus TU, and that will give us the distance from ST, which is what the question was asking us to solve. Well, RS we know to be 3 units, and TU was given as 1 unit. To find RU, remember that's the absolute value of the difference of the coordinates. So negative 1.3 minus 7, which is negative 8.3. And we take the absolute value of that, which is a positive 8.3 units. So 8.3 minus 4 is 4.3 units. Is the distance from point S to point T. Question 3. For each of them, we've been drawing a number line, and it says that point X is located at negative 5. But this time, they also give us a location for point Z. So I will not put this point in the center. And I will say X is here at negative 5. And I will put Z here at 15 units. What point is on the number line between X and Z? So we'll use the letter Y because Y in the alphabet is between X and Z. But you don't have to do that. You could pick any letter. Such that the distance from X to the point is 3/4 the distance from X to Z. So here we are again. The distance from X to the point is 3/4 the distance from X to Z. That is an algebraic equation disguised in the English language. So we want to translate that to algebra. X, y, because y is the letter I'm going to use for the point. So that distance is or equals 3/4 the distance from x to z. Well, they didn't give us here a distance from x to z, but we can calculate it because they gave us the 2 points. So the absolute value of -5 minus 15, or the absolute value of -20, is 20 units. So xz is 20 units times 3/4. And I like, instead of multiplying the numerators and the denominators, then simplifying, I like to simplify first. It keeps the numbers smaller, more easy to manage, and you would probably be very capable of doing the work in your head. For example, 4 goes into 20 5 times, and 4 goes into 4 1 times. Now it's just 3 times 5, or 15, over 1 times 1, which is 1. So we could say that xy is equal to 15 units. So from x to point y, we're going to go 15 units, which would be 10. Because -5 plus 15 is 10. So we can say the point is located at 10. Number 4. A high school football field is 160 feet wide. The ball is placed 40 feet from the sideline. So let's draw. Here's our number line to represent the width of the field. Sideline to sideline. And the ball is placed 40 feet from the sideline. If this whole thing is 160 feet, we could say 0, 40, 80 would be right in the middle, 120, and the total 160. And I'm going to change colors just so that our work here will be seen on this number line easier. So here's the ball. At 40 feet from the sideline. 2 wide receivers for the Bobcat football team are supposed to line up 1/4 of the distance from the ball to the sideline. So this distance is 40 units, 40 feet. But there's another sideline. And we're talking about 2 receivers. So this distance is 120 feet. So we need to find 1/4 of 40 feet and 1/4 of 120 feet. This is going to be 10 feet and 30 feet. Let's go back to the question. Two wide receivers line up a quarter of the distance from the ball to the sideline. And so now from the ball, we're going to go 10 feet back at 30 feet. This is wide receiver 1. And then wide receiver 2 is going to be 30 feet from the ball on this side at 70 feet. And this is wide receiver 2. Now the question asks, how many feet from the sidelines is each wide receiver? So we need to find this distance and this distance. Wide receiver 1 is 30 feet from the closest sideline. And wide receiver 2 is 160 minus 70 absolute value, which is 90, the absolute value of 90, or 90 feet from the other sideline.